Okay, before we get deeply into internal and external rotation of the arm, we have to do a few just basic mechanical points. Here's our little robot that had his arm taken apart so that the parts that obscure how it moves could be seen. And we're going to go back over to this robot, which is the fully functional robot where all of the little parts are still in place. And anytime you have motion, you're going to have the parts that move, shown here by this green upper arm. Of course, the forearm and hand are connected to that, and this green upper arm structural member is connected to this brown structure that rotates around this shaft. And so that's going to be the part that moves. But in addition to the part that moves, you're going to have a part that doesn't move and acts as a base of stability. And for the movement of internal and external rotation, that unmoving part will be this blue shaft. In addition to which, in order to make motion occur, you're going to have a device or structure or mechanical object that provides a power of motion. And the final thing you're going to have is some sort of a linkage structure where the object that's providing the power of motion takes the motion which it can produce, or the motion that it can provide, and takes that motion that it can provide and converts that motion into a motion that is useful to you. Another concept that needs to be discussed so that you will not continue to have the feeling of why in the world is this so complicated, and that is you want the motions of the arm to be independent. We've decided that we have three axes of motion. One axis is internal and external rotation, which is this structure rotating around this blue shaft. A second motion of the arm is abduction and adduction, which is this entire structure moving around these two little shafts here. The final motion of the arm is flexion and extension, where the arm, the internal and external rotation parts, and the abduction adduction parts all rotate around this shaft. And the point we're making here is, in order for the motions to be independent, it's necessary that the structures which supply you with internal and external rotation, when you do abduction and adduction, the abduction and adduction moves all of the parts that create internal and external rotation, so that a movement of abduction and adduction does not alter the setting you have for internal and external rotation. And all of the structures that are involved in abduction and adduction, they have to be moved when you do flexion and extension. And the reason for that is that so that if you have an event of flexion and extension, when that flexion and extension movement occurs, it does not alter the setting of abduction and adduction, and it also does not alter the setting of internal and external rotation. So all of the parts of internal and external rotation have to move with abduction adduction. All of the parts of abduction and adduction and all of the parts of internal and external rotation have to move when you do flexion and extension. Finally, flexion and extension is moving the robot with the base point being the thorax. So the rotating and moving points of flexion and extension move with flexion and extension, but the base points and the anchor points don't need to. And you may say, well, why is it that the one that doesn't move is flexion and extension, and why is it that abduction and adduction is in the middle between flexion and extension and internal external rotation, And why is it that external and internal rotation is the last one out here? And the answer to that question is because that's the way I drew it. I think that works, looks good, and is feasible. And you can redraw it any way you want to. You just have to remember these points, because if you don't have the parts move, then what will happen is motion of one axis will cause a motion of the other axis, and you don't have independence of motion.